We're back. Here we go. There's been a little bit of a break, but we're back at it again. Before we start solving log equations, which is section 5.7, I thought maybe we would do a couple examples from just some previous things for logs because of the break. So let's take a look at this first question. You got this log equation here. It looks pretty tricky. And it says that it's the image of the graph y equal log in base 6 of x after it's been translated, so many things. So if we're going to see how do we take this graph to get this one, we're going to have to solve this one for y first. So we'll just move the 4 over to the other side. So nothing's really going to change, except we'll get subtract 4. Okay, now we're thinking transformation. So we know that this is going to be a vertical translation, so this is going to be 4 units down. So right away I'm going to get rid of anything that says 4 units up. That's not going to be right. 4 units up, that's not going to be right. So it's either going to be this one or this one. Now, question becomes, what do we do with the 8 in the brackets with the x? Well, we know that's always the opposite, right? So if it says plus 8, you're not moving 8 units to the right, you're actually going to the left. So the answer is going to be C, translated 8 units left and 4 units down. Cha-ching! We got that one. All right, what is the x-intercept of this graph? So x-intercept means that y equals 0. So if we go and plug in a 0 for the y, then we can solve it for x. The problem is we have a log. Well, we have a -5 in front. You might be tempted to use the power law and bring it up, but I wouldn't. You're trying to make it simpler. So you can just divide both sides by -5, and 0 divided by -5 is still just 0, right? And then -5 divided by -5 is 1. So you're kind of left with log base 2 of x plus 4. Now it's like, what do we do now? Well, we can go to exponential form, right? So we can say, hey, it's the log base raised to the power of the answer equals the argument. Now that's a lot easier for me to solve. 2 to the 0 is 1, and then I just am solving this equation, so I'm going to move the 4 over to the other side, and I'm going to get that x equals -3. That's easy peasy. Oh no, now they're asking me the y-intercept of this same function. So y-intercept means that x equals 0. Oh gosh darn. Let's see. Let's use my trusty eraser. So, x equals 0, which means I'm going to pop a 0 in here. I'm going to have y equals -5 log base 2 of 0 plus 4. Well, this is going to be a little trickier because I might actually have to deal with that -5. But before we do that, let's see what happens in the brackets here. So we would get 4. Right, so we have log and base 2 of 4. Well, you can solve that, right? You remember that this, it means something. It means 2 to some power equals 4. Okay, so 2 to what power is 4? Well, the answer is 2. So this evaluates out to 2. So you have -5 times 2, which is going to give you -10. Boom! Brain exploding. Okay, what is the y-intercept of this one? Okay, so y-intercept again means x equals 0. So I'm going to go in here, and that's going to be a 0. So it's going to be not 30. Maybe I shouldn't do that. It's going to be 3 minus 0, okay, which just ends up giving me 3, right? 3 minus 0 is 3. So I'm looking at f of x equals -2 log base 3 of 3. Well, once again, you can evaluate that log, right? And remember, when the argument and the base are the same, the answer is 1. The reason is because you're going to say 3 to what power equals the argument. So obviously the answer is 1. So you're going to have -2 times 1, and that's going to be f of 0 equals. So, you know, -2 times 1 is -2. You're done. Woo! We're back into it. Okay, my brain is booted up. So, since my brain's booted up, let's go ahead and start 5.7, doing some log law and exponential equations. This is a heavy section. These are big questions, and they tend to be 3 to 4 marks on the exam, and you can reliably, you'll always find them. Okay, they'll always be on the exam. So, quick review of the 3 main log laws that we learned last time. I guess we'll just say last time. We learned these 3 log laws. So we'll review each one. If you have 2 logs with addition between them, as long as you got the same base, so this is log base 4, you can rewrite it as log base 4 of 100 times 2, which is 200. Okay, so that's an equivalent statement. And I know it says simplify each expression, but that's all they're looking for. Okay, they're not, be careful. They say simplify, so this is simplified. Evaluate would mean give me an answer. So be careful. Okay. This one here, same log base, but we got subtraction. So the log law that we learned there was that, well, it is take the first argument and divided by the second argument, and you can write it as one log. So this was called the quotient law, this was called the product law, and then we also had this one down here, which is just a bunch of stuff going on. Mainly though, when you have a number out in front of a log, that means that it used to be a power. So it used to be a power up in front. So if I'm going to simplify this one, I'm going to write log base 3, and then it's going to be 6 squared. Okay, and plus, this one is log base 3, bring the 3 out, it's 4 to the power of 3, subtract log base 3, 2 to the power of 6. So that's step numero uno. Then what? Well, I got an addition, so I can probably combine those two, and then I have a subtraction, so I'm going to use quotient law. Just work from left to right and do one thing at a time. So I'm going to do the product law first. 6 squared is 36, so that's kind of a big number, so I'm going to go 3, so it's going to be 36 times whatever this is. 4 to the power of 3 is what, 64? Okay, so I just used the product law, right? When it's addition, you can multiply together and write it as one log. And then you still have subtract log base 3 of 2 to the 6, which I think is 64, 2 to the 5 is 32, 2 to the 6 is 64, so we can evaluate that. And now it's like, okay, well, what do we do? Well, we got a subtraction sign, so it's quotient law. So always check and make sure you have the same base, by the way. I'm always kind of assuming that you guys are, but I should say it. So I can write it as one big log, first argument, which you'll notice I didn't evaluate yet, divided by the second argument. Well, that's pretty handy because 64 divided by 64 is 1, so I can finish writing this as log base 3 of what's left over, just the 36, and you're done. Wow, that's a big one. Don't need to go any further because it says simplify, so you simplify as much as you can, you don't need an answer. Okay. What do we have going on next? Oh boy, log equations. Yes, what are the steps to solving them? Well, I promised we would do this. Use the log laws to simplify. Okay, so obviously these questions are going to be pretty complicated, so my steps are going to be pretty general, but yeah, generally you're going to be either combining logs or using your log laws to get it into a simpler format. Now this is important. If you get just a single log, so once you do your simplification, if you get a single log, then you're going to use exponential form to solve that equation. Okay, we'll see lots of examples of that. If you have a log statement on the left side, if a log statement is left on the right and the left side, so if you have logs on both sides after simplifying, you're going to be canceling the logs and then you'll be solving the arguments. So we'll see ones like this. But yeah, basic concept, simplify, remove the log from the equation and solve it is the basic idea. Wow, let's take a look here. The first one I'm going to look at is when you get a log just on one side. So when we're going back to our steps, it's the kind where we're going to simplify and then we're going to have one log left to solve. So what do we got? Well, we got 5 equals a log plus another log. Okay, and it says verify the solution, which we'll do at the end. Well, let's see. Addition means that I'm using quotient law. So in order to solve this, I need to combine this into one log. So I'm going to leave that on this side, and I'm going to say log base 2, multiply the arguments together, so you're going to get 2x squared. Okay, now you've got it simplified where you have a log on one side. So the only way you can solve this at this point is to use exponential form and say, okay, 2 to the power of 5 equals the argument. Okay, and now you can solve this equation for x squared. Well, I'm going to divide both sides by 2 right off the hop. So 2 to the power of 5 divided by 2 is 2 to the power of 4, and it equals x squared. Now just do the square root of both sides. Now 2 to the 4 I think is 16, so basically you have the square root of 16, which is plus or minus 4, and that equals x. Now be very careful, don't forget the plus or minus, but also don't forget to evaluate whether or not these are valid arguments, okay? So we know something about the arguments of logs. They cannot be negative, nor can they be 0, so they have to be greater than 0. So right away, this negative 4 here, when you check and you plug it back into the original, you're like, that's not going to work because I get a negative log right there. Then double check this one. I plug that in, that would be good. Plug it in, it looks good there. This one says actually verify, so they'd like us to go plug in our answer, which is x equals 4, and see if we actually get 5. So let's go verify over here. So if you plug in 4, you're going to get 5 equals log base 2 of 4 plus log base 2. 2 times 4 is 8. Okay, so now we can evaluate this in our head. 2 to what power is 4? Well, the answer is 2. 2 to what power is 8? Well, the answer is 3. And I can see that 5 equals 2 plus 3, so it's verified. Yeah! Back at it again! Example 2. A little bit harder, a little bit more involved. We're going to have some power law in here, but I'm pretty certain that I can combine this down to 1 log. So let's check. Use power law right away. Log base 2 of x squared. Subtract log base 2x minus 1 equals 2. Now I'm in a position where I'm like, I got subtraction. That's quotient law. Same base, right? So log base 2, big bracket, first argument divided by the second argument equals this. Now that's looking pretty complicated. There's only one thing you can do at this point. You got 1 log. You can write it in exponential form. So you can go 2 to the power of 2 equals the argument. So that's just the definition of a log right there. Now you can simplify. So now you're back in grade 10 or grade 11, whatever it is. So 2 to the power of 2 is 4. And I'm going to have to multiply both sides by x minus 1 to get that out of the denominator. Okay, so I got 4 times this. I'm going to distribute that into the brackets. So that gives me 4x minus 4 equals, on this side, those two things cancel, I just have x squared. When you have the x squared and the x term in the equation, you're going to have to factor to solve. So move everything over to one side. Try to keep your x squared term positive so you don't have to do decomposition or anything. So I'm going to subtract 4x, and I'm going to add 4. That would give me 0 on this side and this equation to solve. Well, that one's easy enough. That's just a perfect square trinomial, right? 2 numbers that multiply to 4 and add to -4. So -2 and -2 would work, which means that when you solve for x, you just get x equal 2. Now, double check, always double check. When you substitute it back into the original, do you get a negative argument or a 0 argument? That looks good. 2 minus 1 is 1, so that looks good. We won't verify this one. Okay, generally as long as you don't get a 0 argument, it's going to be fine. So we'll just be lazy because these notes will be long. And we'll move on to the next one. Ooh, here we go. Logs on both sides. These are my favorite ones. Because I think they are sort of easier. Yeah, we'll see though. Okay, so you're noticing you got logs everywhere. You still have to simplify as much as you can. You won't be able to solve it if you have 2 logs on one side and 1 on the other. So over here, we got power law happening. Okay, so we can bring the squared up. Over here, there's not a lot I can do, so I'll just rewrite it for a second. And then over here, nothing I can do, so I'm just going to rewrite it. That's great. All right, what now? Well, I can use quotient law over here because I got a subtraction sign. Okay, so that means take the first argument divided by the second argument there. So now we got 1 log over here, and we got 1 log over here. Not sure why my pen didn't pick up there. There. What now? Well, let's think here for a second. Do we have the same log base? Well, we don't have a log base, which means the base is 10. So there's some review for you. So the log base is 10. So if these are indeed equal, I got some log in base 10 with some argument equaling some log in base 10 with some argument. So it logically follows that if they're equal, then the arguments must be equal, okay? So we call this canceling the log, but you're really not canceling the log. You're just using logic to be like, this argument has to equal this one. The effect is, it looks like the logs disappear, okay? But we're not actually canceling them. Okay, it's a very small brain shift there. Now we can solve this for x, yeah. So we have an x plus 2 down here, so we're going to have to multiply both sides by x plus 2 to get that out of the denominator. So on this side, that's going to cancel out to 1, so you just have x squared. Over here, you're going to have to FOIL this out, so we're going to get 2x squared, and then you're going to get 2x times positive 2, which gives me positive 4x. This one times that one gives me negative 3x. Negative 3 times plus 2 gives me negative 6. So now here we are. This is looking great. I need to move everything over to one side, and I'm going to try to keep my x squared term positive. So I'm just going to subtract x squared on this side so that I get 0. When I subtract x squared from here, I'm just going to get x squared. Combine those like terms, so you get plus x minus 6. Now you have a nice little neat equation that you can factor regularly from grade 10. Two numbers that multiply to -6 but add to 1. Well, it have to be +3 and -2. Then I'm going to solve for x. So I get x equals -3. Or on this side, I get x equal 2. Now, double check. Just because you have a negative number doesn't mean that it's going to work. Doesn't mean that you cross it off, right? You need to check and make sure that when you plug that negative number in, you don't get a negative argument. We get a negative argument right here, okay? So we would have log of -3, which would not be allowed, so we can just cross it off. You don't need to give a reason on the exam. If you cross it off, it's understood that you rejected it for some reason. Let's check the 2. So 2 would be good here. If we get 4 there, and here we get 4 minus 3, which is 1. So this should work. Boom, done. You basically see all the different kinds of questions you can see. Great. This is amazing. Here's another one. Very similar kind. It's actually a try it yourself. So I'm going to give you the answer and maybe a little hint to get you started. Because we just did one exactly like this. So the answer at the end that I got was x equal 3. You will reject x equal -2. So there's a little hint for you. And let me show you just maybe your first step, okay? So nothing I can do on this side. Here I need to combine. It's product law because of the plus sign. So I'm going to write log x plus 6, x minus 1. Now if you want to pause the video, try it and see what happens, great. But at this point, you now have one log on this side, one log on this side. They have the same base and they're equal. So the arguments must equal each other. So I just say, hey, 6x has to equal this argument right here. Okay, then you would FOIL it out, group your like terms, solve for x. That's the answers you should get. Good luck! Feel free to email me or talk to me if you're having trouble. So 2 more. What about these 2? Well, this one is especially tricky. So it says you cannot cancel log on both sides because of the 3. Okay, so I would catch the people who aren't quite sure why they're canceling log. You know, you can't just cross off the logs. You got a 3 there. Okay, so somehow you have options. You must bring the 2 log statements to one side. Yeah, you could bring this log statement over here and then combine it. And then you would have one of those first kinds of questions we did where you have one log and a number on one side. Or you could equivalently rewrite the 3 as something in log base 2. I don't recommend doing that. That's tricky. Let's just get one log, okay? Get one log, one log. Okay, so we're going to add this to both sides. So we'll add that to both sides. I'm going to rewrite. So I'm going to have 3 equals log base 2, the first one, x plus 2, plus this one, log base 2 of x. Right? So what happened is those ones canceled, right? Negative and then positive of the same thing cancel. I can use product law to combine those together. So it's the first argument times the second argument, which is just x. And now what? When I had this kind, I had to use exponential form. So I go 2 to the power of 3 equals the argument. Now I'm going to go ahead and maybe distribute this into the brackets. I'm going to get x squared plus 2x. There we go. And then I'm going to have to solve by factoring because I have the x squared term and the x term. So this is 8. I'm going to subtract 8 from both sides. So on this side I get 0. Then I have x squared plus 2x, subtract 8. And I can factor that, easy peasy, lemon squeezy. 2 numbers that multiply to -8 but add to +2. That's going to be +4 and -2. I'm going to get x equals -4 on that side. Over here, I'm going to get x equal 2. Double check and see if you're going to get a negative argument. So when I plug in -4 in there for that x, that's going to give me a negative argument. So this gets tossed. I mean, very often when you get an x value that's negative, you're going to toss it. But you're not tossing it because it's negative. You're tossing it because when you pop it into the original equation, you're getting a 0 argument or a negative argument. You still have to check this one. So it's good in there and it's good in there. So that's a solution. Woo! Done. All right. What else have you got? Another very similar one, I do believe. We're getting there. We're on slide 9 of either 18 or 13. So I think it's 13. So this one here, very similar to the last one. It's actually going to be the try it yourself. So very, very similar. I'll get you started and then I'll give you maybe the solution, or who knows, maybe I'll end up doing it. Let's see. So I need to get this log over here. So I'm going to add this log to both sides. I'm going to try to do a little bit less writing here. So I'm adding that to both sides. Okay, so that's what I get on the left-hand side. On the right-hand side, I'm just going to have the 1. Okay, now I got product law. So I'm going to rewrite this as x plus 3, x plus 4 equals 1. And now I'm like, okay, I got 1 log. I can write it in exponential form. I can say 6 to the power of 1 equals the argument. Now, to solve this, I'm going to have to FOIL this out and move the 6 over to the other side. So 6 of the 1 is 6. So I'm going to subtract 6 from both sides. Over here, I'm going to get x squared plus 4x, and then I guess I'll write it out. 3 times x gives me 3x, and then 3 times 4 gives me 12. And don't forget, I subtracted 6 from both sides, so I better do that. There. Now I can group my like terms. So here I'm going to get 7x, and then here I'm going to get 6. And I'm going to factor 2 numbers that multiply to 6 but add to 7. Well, that's going to be 6 and 1. There we go. So this is going to give me -6 or -1. Perfect. Now, let's see. Finally, we get one of these questions where maybe we have to keep a negative answer. Let's see. When I plug in -6, I'm going to get -3 as an argument here, so I can toss that right away. For -1, if I plug in -1, here I get 2, and here I get 3. So that's okay. So that's actually a valid answer. X equals -1. Wow. So just be careful. Just be careful. All right. Well, what do we have left? Well, we're almost done. We got exponential equations, right? So we know how to solve these ones from back in the day, 2 to what power equals 8. And we learned how to use logs to solve 2 to the x equals 7. And now we're going to basically expand that idea using the log laws for basically more difficult questions. Yay. What does it mean for us? Well, it means that we might have to solve stuff like this. There's no obvious answer. We can't solve it the regular way, right? So we can't, the regular way was when we tried to get the same base, right? Like we'd say, hey, well 9 is 3 squared. But then how do you write 50 with a base of 3? You can't. So we have to use logs, right? Got to use logs to solve it. How do we use logs to solve it? Well, it's an equation. So as long as we do the same thing to the both sides, then it's okay. So if I apply logs to this side and logs to this side, that should be okay, right? I did the same thing to both sides. Now I can use my log laws in order to solve for x. This is power law, so I can bring the x down. So I get x times log 9 equals log 50. And what now? Well, I can divide both sides by log 9, right? That's just a number. So I'm going to get log 50 divided by log 9. Now I have a numeric expression for x. And you wouldn't be expected to do really a lot else with that. I'm just double checking. Yeah, that's really all we can do there. Okay, so let's try another one. Another. Oh boy. Now this one, at first glance, you might say, oh, I can rewrite 6 as a base of 2. No, you can't. So then what? It's like, well, what are my other options? Don't divide both sides by 2, because you see that happen all the time. So it's 2 to this power equals 6 to that power. You can't divide out your base. Okay, so don't do it. If you're in this situation, you're going to apply logs to both sides. You just say, okay, I got log 2, x plus 3, keep the brackets around it, equals log 6, x minus 1, keep the brackets. Now you can start solving for x. Use the power law, so bring the x plus 3 down, and that's times log 2. Bring the x minus 1 down, and that's times log 6. Well, this is going to get really ugly really fast because you have x on both sides. So what would you normally do back in grade 10 or 11, like if you just had a number times a bracket, you would distribute the number into the brackets. Well, remember, this is just a number, so I'm going to distribute it into the brackets, and I'm going to write x log 2 plus 3 times log 2 equals, bring this into the brackets, so you get x log 6, subtract log 6. Now what? Well, we need to isolate x. So let's bring all our x's to one side and push all the numbers to the other side. So I'm going to subtract this from both sides. So here I have x log 2. I'm going to subtract that one. So on this side, that's gone. I'm going to also get rid of this number, so I'm going to subtract 3 log 2 from both sides. So over here I have negative log 6, subtract 3 log 2. We're almost there. Now remember, you're trying to solve for x. So what's the only thing these two things have in common? They have x in common. So pull out the x. So you would get log 2 subtract log 6, which is some number that, thank God, we don't have to calculate. Then we have this. So I'm going to recopy all that garbage. All that hot garbage. There, we're almost there. So we basically have x times some number equals some other number. How would you solve, 2x equals 5? Well, you would divide both sides by 2. So I'm going to divide both sides by this statement. So I'm going to get x equals the numerator divided by the denominator, log base 2 subtract log 6. Oops. Oh, I didn't know I could move that thing. There. Yes. Oh, that's really ugly. This, not me. This is really ugly. The good news is you get to leave your answer like this. You don't need to simplify anything. You just leave it like that. You get questions like this on the exam all the time. They're generally 4-mark questions. They're pretty big. So enjoy. Here's another one. There's a couple ways to do this one. And as long as the methods are valid, you're good to go. So what I see when I look at this one is I got 2 times this thing with a variable in my exponent equals 100. Well, the way I see it is I can divide both sides by 2. Now I can do that because I'm not doing anything to the base of this. Okay, so I can't multiply them together, but I can go 2 divided by 2 is 1, so that gives me 5 to the power of x minus 2 equals 100 divided by 2 is 50. Okay, well now what? Is there a way to write 50 using a base of 5? Well, 5 squared is 25, so no, not really. So at this point, I need to use logs, so I'll apply logs to both sides. Now I will put brackets around my exponent. There we go. So I'm going to use power law to bring that down. Now I got x minus 2 times log 5 equals log 50. Well, unfortunately, there's a couple ways you could do it. What would be the easiest way? I mean, many of you might be tempted to distribute that into the brackets, and you certainly could. But it's also a number, so you could divide both sides by that number. I'll just do it the most regular way. I will just distribute it into the brackets. I'm going to have x times log 5 subtract 2 times log 5 equals log 50. I think that's sort of what we're used to doing, right, is generally distribute it into the brackets. So now I can move that over to that side. Right, so add that to both sides. So you get log 50 plus 2 log 5. And now we have x times that log, so just divide both sides by log 5. Everything on this side by log 5. And you're going to get x equals log 50 plus 2 log 5 divided by log 5. Now you might be tempted to try to simplify, like you could use power law and bring that up there, and then you could use product law to combine those. But the good news is you actually don't need to. So on these questions where they say solve for x, I just solved for x. Okay, so I have a statement that x is equal to, and you're just going to leave it at that. So that's the way I would do that one. It's a particularly ugly one. So yeah. We got more. I mean, we can do these all day. Got 4 more slides. So, I mean, here's another one. It's more of a try it yourself. At this point, we've kind of covered all the strategies. So what I might do here is give you a final answer for this one, and you can try it out yourself. I will say, like, there's no way you're going to write 19 with a base of 3, right? So 3 squared is 9, 3 to the power of 3 is 27. It's not going to happen. So your first step is going to be apply logs to both sides, right? So this is your first step. Right, so we've already done a question like this. So doing another one, well, that's your job on the homework, right? Then you can use power law, bring it all down. When you get to the end, your final answer, let me just grab it. Oh, it's an ugly one. Oh, it's very ugly. Oh, so ugly. We're going to get 5 log, is that a 19? Yeah, it is. Log 19 plus log 9 divided by log 19 minus log 3. Okay, beautiful, great, oh, wonderful. Okay, yikes, ugly, ugly. Email me if you're having trouble, for sure. Okay, again, this is another try it yourself. I actually didn't work this one out, but I will say, I will maybe get you started on it. So you might be tempted to divide both sides by 2, but you can't divide a base that has an exponent, okay? So if it has a variable in the exponent, you can't go 8 divided by 2, okay? Because that's going to affect the value of the variable. So you're not going to be able to deal with that. This one, you need to apply log to both sides right away. Maybe we should just do this one because it is a little tricky. What are you going to do? On this side, you need to bring the x minus 2 down. Okay, on this side, this is especially tricky. You got something times something else as the argument. So you can use product law there and you can split it up into 2 logs. You can write log of the first thing plus log of the second thing, right? That would have been product law. If you go backwards, you got addition, you just multiply them together, you would get that. Now I can use power law to bring the x down. So I might actually just sort of sneak in there with my eraser and bring the x down in front just to save myself some writing. Okay, so I brought that x down in front using power law. Now I can distribute the log 8 into the brackets. So I get x log 8 minus 2 log 8 over here. Over here, there's really not a lot I can do. You know, I might just bring the log 2 over to this side. So I'm going to subtract log 2 from both sides. Okay, so it's gone over here, and I'm just left with x log 5. Now let's see if you remember. You're trying to solve for x, so you need to move that over to the other side, right? Get all your x's on one side. So I'm going to subtract this from both sides. So what I'm going to do to be lazy, I'm going to cross it off here and write subtract x log 8. And I'm going to go ahead and erase it now. So I just moved it over to the other side. And then it's like, oh, I got this thing with a bunch of x's equals this number. I can pull the x out here. So that would leave you with log 5 subtract log 8 equals all this stuff. I'm just going to go na. Okay, so just recopy it. I'm not going to. Pause the video if you like. Divide both sides by this. So you get x equals whatever's in the numerator, which remember, we don't need to simplify at all. So we can just leave it like that, divided by log 5 minus log 8. There you have it. You saw it here first, people. There it is. You don't need to go any further. I know it's ugly, but yes, you get these questions on the exam. And they are brutal. But if you study, you're going to be just fine. So, last thing, we've covered everything at this point. I just want to spend just one quick minute reminding you of basically the 2 different kinds of questions we saw, right? So they're like the 2 kinds of equations. So you're either going to have log equations where you're attempting to remove the logs and simplify, or you might get exponential equations where you have a log on one side and then you write it in exponential form and solve. So can you see the difference between the 2 different varieties here? Well, this one here, if you give it a shot, I might recommend that you actually pause and give it a try on your own. There's nothing new here, right? So pause the video, see if you can do it on your own, and I'll do it real quick. So I'm going to have to combine all my logs on this side. I have addition there, so I'm going to write log base 2, x minus 2 times x equals log base 2 of 3. Now this is the kind where you have logs on both sides. If you have the same log base, which you do, then the arguments must equal each other. So now I can write x minus 2 times x equals 3. Okay, distribute the x into the brackets, subtract 3 from both sides, now it's equal to 0, solve it for x, right? So you're going to get x, 2 numbers that multiply to that, add to that, going to be x plus 3, x plus 1 equals 0, so you're going to get x equals 3 or x equals -1, double check. This is going to give me a negative argument right there, so that's canceled. This one is going to be 1 here, 3, this is good. Done. Booyah! One more question. Here we go. Step right up, step right up. The exponential type question. Okay? So, exponential type question, for these ones, the only way to solve them is to apply logs to both sides. So we just saw one very similar to this. So I'm going to give you the first step here. First couple steps maybe. This is that harder variety, the last one that we just did. So you apply logs to both sides. And then you got to split this up. So you got 3 times 7 to this power x minus 2. So you can use product law there. So I can write log 3 plus, I'm going to leave myself some room, log 7 x minus 2. And then over here, I'm going to use the power law to bring that down, so I get x log 4. There's my equal sign. I left myself some room here because I'm going to say, hey, you're going to need to bring this down using power law. So I'm going to erase that and bring it down in front. So I get x minus 2 times log 7. So I just brought the exponent down in front. Okay? From here, you should be fine. You should be able to take it and solve, right? You're going to distribute the logs into the brackets, get all the x's on one side, all the numbers on the other, pull out the x and divide. I will give you the final answer. It's an ugly one as usual. You get log 3 minus log 49. Where did that 49 come from? It came from I'm just going to do this. If it was the answer I wrote, I did some simplification. So I'm going to go ahead and do this. Change my mind. I don't want to leave it hanging. So I'm going to distribute the log 7 in. I'm going to leave that like that. We got log 3 equals, oh boy. It's just so much writing. Okay, so I have all these numbers. We're going to move this over to this side. So we're going to get x log 4 minus this because we have to subtract it. On this side, we have log 3 subtract 2 log 7. Now, you don't need to simplify this, but you could bring the 2 up as an exponent and write it as log 49, which is what I did in my answer, but you don't have to, okay? We're going to pull the x out. So I'm just going to be pulling out the x here. So I'm going to get log 4 subtract log 7 equals that stuff, okay? Don't ever do that on the exam, but I'm going to do it here to save some time. Okay, so now I'm going to take this and divide by that. So I'm going to write log 3 subtract 2 log 7 divided by this stuff, log 4 subtract log 7. Don't touch it. Don't do anything else to it. Leave it like that. You're done. Boom! That was brutal. Thanks for sticking with it. You can now do exercise 5.7. Good luck and see you next time.